Hello, I am Mariano. I am the product manager of OpenHEXA, and in this video, I'll give you a walkthrough of OpenHEXA, and I'm hoping to show you how OpenHEXA can help you deal with real-world integration issues, challenges by going through a particular example. So, as context, what we're going to be using is a playground Sierra Leone DHS2 instance where the raw data lives for Sierra Leone. And we're going to be calculating some custom reproductive health environments for 2024. And so the question that we want to answer is, what is the ANC first visits ratio per 1,000 pregnant women at the provincial level? In order for us to calculate the ratio, we need the total number of pregnancies, which we don't have in this DHS2 instance. We need to get it from somewhere else. Also, we don't have the provincial level in the hierarchy in this particular DHS2 instance. We only have data at the district level. So we'll have to map those districts into the respective provinces in order for us to do the aggregation, and we'll have to bring that data from somewhere else. Typically, you would bring the data from, the boundaries data from an administrative database like GADM. You would get the pregnancies from World Pop, for example. And of course, you continue using DHS2 for the indicators. And this is exactly what we are going to be doing in OpenHEXA. So here I'm going to be explaining a little bit the workflow that we're going to be following in the demo to follow. So as I said, we're going to be extracting boundaries data from GADM. We're also going to be extracting pregnancies from World Pop, and with these two files, we're going to be calculating pregnancies per province data set that we're going to store in OpenHEXA's in-house database. We're also going to be pulling data from DHS2, so the indicators, the ANC first visit indicator, and we're going to be bringing some other data elements as well to enrich a little bit the dashboard that we're going to be doing at the end of the exercise. ANC first visits, and then we're going to calculate the custom indicators also within OpenHEXA by using these two tables as inputs, and we're going to see all of this data in a nice dashboard. So without further ado, let's jump into it. Okay, so I'm now positioned in an OpenHEXA workspace. This is a brand new empty workspace that I created for this exercise. I'm going to try to replicate the workflow that I just described from scratch, and hopefully you'll see how easy it is to go from scattered data sources to data integration analysis with OpenHEXA. So the first thing that we would want to do is to go to pipelines, and you'll see, of course, I don't have any pipelines yet available in this workspace. But the nice thing about OpenHEXA is that it comes with a set of ready-to-use template pipelines. So as you know, you can create pipelines, data pipelines in OpenHEXA by coding your own logic, either in a notebook or in your local environment and pushing it to OpenHEXA through the CLI. But you can also leverage already pre-built, a wide set of already pre-built pipelines. And this is what we're going to do in this case. So if you remember, the first thing that we needed to do was to extract boundaries, the different administrative boundaries, so the map of the country at different levels. And we want to extract also the pregnancies data from World Pop and aggregate that spatially, right? Okay, so the first thing to do is to retrieve that map, right? So we're going to search for GADM, which is the source that we're going to use for our country boundaries. And this is an extraction pipeline, so this seems useful. So we're going to create a pipeline based on this template. And there it goes. It simply appears now in our workspace, and it's ready to use. So looking at the description, this extraction pipeline is going to generate one GPKGA file per administrative layer. This is an example. So we're going to run it and see what we get. Okay, so here we need to provide the country code, so Sierra Leone, and we need to provide an output directory. So as you know, OpenHEXA comes with a file system integrated to it. So this file, this JPKJ file, is gonna be stored there. So let's call it boundaries, and let's run it. So now the job has been queued and now it's running, and you can see the different messages that the process is going to be providing us to inform where we are. Okay, so it's downloading the data from GADM. It's splitting the data set into a different administrative layers. Fantastic. We now have our boundaries files stored in OpenHEXA and ready to be used. They are stored in this directory, and we can download them or not. Fantastic. We have our boundaries in OpenHEXA now ready to use. Now we're gonna create another pipeline. This time we are gonna be extracting and aggregating the data for pregnancies. So we're gonna search for pregnancies in templates. So we have an extract pregnancies from WorldPop. That seems interesting. So we're gonna create a pipeline out of that. And there we go. So we have the pipeline ready to use in our environment. We need to provide the country code as well as we did for the boundaries data. The boundaries file, so we're going to need to put as input the boundaries file that we downloaded from GADM just now. And this is going to provide an output in the form of a database table, but also we can export that in Parquet or any other file format that we want. As a reminder, the WorldPop information that we're going to be extracting is a raster file, so the aggregation is going to be done spatially using the maps that the boundaries that we have downloaded from GADM. Okay, so we are ready to run this pipeline. So again, we're going to be doing this for Sierra Leone. We're going to be providing the boundary file. In this case, so we need to provide, given that the DHS2 data is going to be aggregated at the district level, we want to provide a district administrative level so that we can aggregate pregnancies at that level and then move to the provincial level once we have that in sync. So we select the district level boundaries. We are going to be creating a table called pregnancies, and let's also create a Parquet file export based on the output of the processing of this information. Click on run. Now the job is queued and it's running. So it's basically first going to be extracting the raster files from WorldPop, and then using the boundaries data to do the spatial aggregation. Okay, so the process finished, and we see that the data pipeline extracted the raster file for Sierra Leone from WorldPop in terms of pregnancies, and it runs the spatial aggregation based on the boundary data set that we have provided, and it gives us as an output a CSV file and a Parquet file that we can download from the OpenHEXA file system, and also the data has been written into a database table. So if we go to database, you see here this database called pregnancies. That was the output of the pipeline that we just ran, and we see that we have calculated number of pregnancies per district using the spatial aggregation logic of the template pipeline. Okay, cool. Now we have our pregnancies data from World Pop in OpenHEXA, and it's aggregated by district, and we have the link to the provincial level. So this gives us an important piece of our custom indicator, but now we need to extract the actual base of the indicator that we want to use, that is in DHS2, and therefore we need to go and connect to DHS2 and extract the data elements that we are interested in. So for that, the first thing that we need to do is to effectively create a connection with DHS2. This is a very easy thing to do. You come here, you create your connection, you specify it as a DHS2 instance. I'm gonna name it DHS2 play, and describe it as such. And I'm gonna be using this play ground instance from DHS2, for which the credentials are admin district. All right, now the connection is created, and I can from now on access DHS2 data from OpenHEXA. So once again, we go to pipelines and we search for a template pipeline that would help us extract data elements. And we see that we have a lot of DHS2 related extraction and transformation pipelines. This one seems relevant. We want to effectively extract data elements, particular indicators from DHS2. So we're going to select this one and create a template out of that. Okay. These are the parameters that the pipeline expects, but let's just run it and figure out the parameters while we go through the form. So the first thing that I'm gonna need to specify is the connection. So I previously created my DHS2 connection, so I'm gonna be able to specify it here. Okay, so I'm now connected to DHS2, and therefore all of these parameters will be populated with the information coming from that specific DHS2 instance. So in terms of data elements, we said that we want to bring ANC first visit. And let's just also calculate a simple ratio between low birth weight and total births. So I'm gonna bring these two and live birth, just to enrich a little bit the dashboard. All right, let's bring these 4 indicators. So we are going to be selecting Sierra Leone as the organization unit. So we're gonna bring everything that we have at the different levels, and we're gonna include all of the children organization units. And we're gonna be doing this for 2024. Okay. December. All right. And we're gonna store this in a table that we're gonna call DHS2. All right, I think we have everything in place. We're gonna run this pipeline, and this is gonna, again, connect to DHS2, extract the data, and store the indicated data in the different output parameters that I specified. Let's run that. So it's reading the data. Awesome, the pipeline finished successfully, and it basically extracted the data values that I specified, and it has written a Parquet file in my file system in OpenHEXA, and also it has created the table as I specified if we go now to the database, we should see this DHIS2 table now with the indicators data populated for the different levels that we've specified. Okay, quick recap of what we've done so far. So first of all, we extracted the administrative boundaries of Sierra Leone from GADM using template pipelines, and we stored those files in the OpenHEXA file system. We then extracted the pregnancies data from WorldPop, which is a raster file, which is again stored also in the file system of OpenHEXA. And with those two files, we basically spatially aggregated the pregnancies data by district and province, and we have a nice table in the database with that information. We then extracted different indicators from DHIS2, particularly ANC first visits, which is the composite indicator that we're interested in, but we also exported live birth and low birth weight in a nice database table ready to use. So we are ready now to calculate the indicators that we want to calculate. And for that particular step, I chose to do that in a notebook so that I can show you that you can not only leverage template pipelines to do a lot of things, but you can also add your own scripts, your own logic to your pipelines, and it's very easy to do so. So I created this very simple Jupyter notebook where I'm basically reading in from those tables, calculating the indicators. So I'm basically calculating a simple indicator, which is the ratio of low birth weight versus live birth, and also the indicator that we were actually interested in, which is the ANC first visits per 1,000 pregnancies. And this is all, of course, going to be aggregated at the province level, so we're going to see that. Okay, so I have my script, which I'm able to test, and I know that it's working. So let me show you how you create a pipeline out of that script. All right, so you go to create, and then from notebook, you name your pipeline. Conceptually, this would be a transformation kind of a pipeline. And then you simply select the notebook that you want to run. Then you create your pipeline based out of that. And as a data pipeline, it has all of the attributes that are associated with them. So you can schedule them, you can run them through the run button here. You'll see the logs, and you can receive notifications if the pipeline fails. All right, so let's run it. And with that, we would be finishing this exercise. This script will be calculating the final indicators for us and would be creating a database table with the final outputs of our calculation. Okay, great, it's done. It's finished. Our table is created, and it actually also created a data set out of these calculated indicators. And we'll see that in a bit. All right, so I have also in my workspace environment a dashboard that is connected to the database table that this script populated. So let's maybe go first to the indicators table. So basically, this is the output of my script. And I have also, as I said, a dashboard that is connected to that data set, and you can see basically the indicators that we were aiming to calculate. And furthermore, the last step also created a data set, which is present here. You can see it's basically the same data, but it is in Parquet format. And the nice thing about this is that the dataset artifact enables you to annotate this data if you want, So at the column level, you can add metadata to the columns. But I think more importantly, you are able to share this dataset within your organization or with specific workspaces that you are interested in sharing this dataset with. So this means that data scientists don't have to start over and do the integration yet again. You can share the final results of your work with other workspace members so that they don't have to start from scratch. Thank you for joining me in this demo, and I'm Mariano, and I'll say to you goodbye. Take care.